Students, so we are going to start the lecture number 20 and this will be the last lecture from my side. From next onwards, Professor Pratik Ray will deliver the lectures. So, in this lecture we are going to look at the aspects of mapping of materials and a bit of data repositories. Data centers, data repositories are important concepts which are going to be affecting material informatics in years to come. So, we will discuss about these aspects and then wind up. So, this is what this is. So, in the third chapter, that is what I mentioned here, the machine learning models and applications. I discussed linear models, SVM, DT, neural network, clustering, model selections, visualizations and some discussion on transformations, right. So, the fourth chapter or fourth important part of this course, we have to discuss about data repositories and featureizations. So, I am not going to discuss much about this. Professor Pratik Ray will deliver the lectures, merit lectures on these aspects, but for the first few important things like data in material informatics and mapping of materials, these are the two aspects we are going to discuss today. So, in the last lecture I talked about model selection, right, how you select models, how do you evaluate models and the various kinds of accuracy parameters I discussed about. Let us look at it again. So, as you know, in model evaluation there are 8 important aspects. First is the training versus test data splitting, and that is normally 80 to 20 or 70 to 30 ratio we do it. We use measured data for training and leftover whatever 20% or 30% data for testing a model. But you also sometimes do validation test. This is normally not a mandatory thing, but it is recommended. So, what do you do with validation test? We always keep some amount of data set to validate our predictions, right. So, every time you develop a model, you can use it for certain predictions. In order to check the predictions, we can always use experimental data to validate. So, that is what is called validation set. But on the top of which you have what is known as a cross validation. I discussed in the last lecture detailed manner. Cross validation is something which is used for validate the important parameters of the model. So, here what we do, we create k, we what is called is we use what is called as a k fold validation problem. In that case, we have data sets which is divided into 1 and k minus 1, and then we can always use these different data sets for validations. Okay. Other than that, we can use different evaluation matrices depending on the type of problems, like in classification we use accuracy, precision, recall, F1 score, ROC and AUC, and for regression we can use the parameters like MAE, MSE, RMSE, R square, some more. We can always use baseline comparison like predictions of the model with some other baseline models, we can do that. And at the end, we need to also address the biases and the fairness of the predictions. You have to understand that many of these models may not be fair enough for the data sets we are using. So, you must be thinking what is that? Well, fairness does not mean the in terms of wrong things or wrongdoing. Fairness means how fair the model applied to the data sets we are using. Okay. So, that is what is called fairness, and that we must probe, and these aspects we are not discussing in details because they requires lot of discussions. And obviously, after you deploy it, you need to monitor the post deployment aspects. So, these are the 8 different things we need to consider when we talk about model evaluation. So, in model evaluation, important aspect is the confusion matrix. Okay. That is used for classification problems. So, here we create 4 different sets of aspects, as is mentioned here: true positive, true negative, false positive and false negative. So, true positive is the case where model correctly predicted something or predicted a positive outcome, and the actual outcome is basically positive. So, what we are doing here basically comparing the predictions made by the model with the actual results. Okay. So, I am sorry about some spelling mistakes like here extra words, but we compare that and then show whether the model is actually right or wrong. So, true positive is something where we have predictions is positive as well as outcome is also positive, actual outcome. True negative something and the prediction is negative and actual outcome is also negative. False positive is that model is incorrectly predicting something positive, but actual outcome is actually negative. Sometimes this is called a type 1 error, and false negative is something in which model incorrectly predicted a negative outcome and actual outcome is basically positive. So, therefore, these are the 4 different ways we can put the data from the predictions of the classification model. So, based on these confusion matrix, we can have accuracy, precision, recall, F1 score and specificity. Let us talk about accuracy. Accuracy is defined like this. It is nothing but a total statistical measure of how well binary classification test correctly identifies or excludes the conditions. That means, this tells you proportion of the correct predictions, true and positive and true negatives, vis-a-vis total number of actual cases examined. Like here you see it is 2 positive plus 2 negative divided by total number of predictions, 2 positive, 2 negatives, false positive, false negative, right. That is what is basically called accuracy. In precision, what do you do? Positive and negative predictions values are proportions of positive predictions or negative predictions statistics. So, we can use them as a diagnostic test and define precisions. Precision is number of 2 positives divided by number of 2 positive plus false positives, basically that is what it is called precision. It also gives you idea how correctly this positive prediction values are predicted vis-a-vis total predictions of false, negative, false positive and true positive. Okay. Now, we also need to consider recall, because it is a measure of how good a model is predicting the positives. Okay. Other two did not do that. So, it shows proportion of 2 positive detected out of the total actual positive instances. Remember, this is defined as a true positive by 2 positive plus false negative. So, if I go back a little bit, accuracy talks about all the proportion of correct predictions from the total predictions. Precision talks about total number of positive cases, okay, from the true positive and false negative cases. But on the other hand, recall is talking about it, how the model is doing in terms of proportion of 2 positive cases out of the actual positive instances. You have 2 positive versus 2 positive versus false negative. Now, F1 score is basically arithmetic, harmonic mean of both recall and precisions. That is defined as a 2 into precision to recall divided by precision plus recall. And it measure is basically measure of a test accuracy. It is calculated from precision recall, and the precision is the number of 2 positive results divided by total number of positive results, and recall is something I talked about it. Recall is nothing but a proportion of 2 positives detected out of the actual positive instances. So, this takes F1 score takes consideration both the precision as well as recall and consider the harmonic mean of that. Some cases we need to consider specificity, right. Specificity is nothing but number of 2 negatives divided by true negative plus false negative positives. Okay. So, basically it tells you proportion of 2 white total 2 negative cases fair in terms of true negatives and false positive cases. So, as you can see here, in low specificity you have lot of false positive cases, but high specificity you have very less number of false positive cases. So, that what you want is a high specificity of a model for a particular application, right. It should be specific to that application. So, from the data sets which you are using, the model must be selected in such a way that is specific to the particular problem which you are going to handle. That can be easily obtained by looking at how many false positive predictions has been made. If it is less, then it is specific to that application. If it is more, it is not. So, you can decide on that. So, in a nutshell, I put it everything: precision, recall, accuracy and F1 score is one slide for your purpose. which you can read it and understand it. Remember, this is used for classification problems, and in material science you are going to use many large number of classification problems, and this is how the evaluation matrix is used. Well, there are regression models also, where you cannot use the confusion matrix, you have to use other matrices. I discussed about it. First one is called mean absolute error. It is defined in this way. I already discussed in the last lecture on the board. You can go back to lectures. It is 1 by n summation j goes to 1 to n y j minus y j hat. Okay. So, y j is the actual prediction, y j hat is the prediction on the model. Its detailed things are written here. So, you can go through in a spare time, and it is basically crucial performance parameter. It is easy to understand, interpretable, reliable, and it is basically mean of all absolute error. This you should understand, is a mean of all absolute error. Okay. It tells you the measure of absolute average size of mistakes in a collection of predictions, and it does not talk about any direction into account, because it is using mod value, right. So, you can also use mean square error, that is why it is a mean of the square of all errors, and it is defined like this. So, we take a square of the terms y I minus y hat I square. In the MAE, we have also considered the absolute differences. Here we are considering the square. When you use the square, you simply remove all the negative aspects. So, it is always square deviation in terms of average square deviation, we can talk about it. In terms of more such aspects, RMSE is very useful. It is calculate basically residual. In machine learning, something residual is widely used. There are a lot of models which actually are developed based on residual corrections. And residual is difference between a prediction and a truth for each data point, and it is defined like this. Basically, you are taking a root of MSE, and you can see that it is extremely helpful to have a single number to judge a model performance, and whether it is used in during training, cross validations, or monitoring even after deployment. Root mean square is one such most widely used measuring quantity. So, therefore, this is more widely used than the MSE and MAE. Now, another parameter which is widely used is called R square, or what is called coefficient of determination. It is a measure that provides you information about the goodness of fit, how fit your model is. So, you have a lot of data, you are fitting with a model, how good fit is that. You can use this as this. You can see here, this is 1 minus y I minus y I hat square divided by y I minus y bar. Y bar is the mean actually, remember that, and the rest of the things I have already defined like that way. So, it is basically 1 minus sum of square regression divided by total sum of squares, right. That also you can consider, but anyway, you may be using R square quite a lot. It is widely used in MATLAB or even Origin kind of software. So, now we will move into the data and material informatics little bit. That was the recap. As you know, data mining is a part of material informatics. You are going to mine a lot of data in terms of that. So, what do you do in data mining? First, you have data sources. There may be papers, published papers, some files, web documents, scientific informations, or various database systems which are people are going to provide. There are a lot of open databases you can see. I have shown you in my earlier lectures also, but you can also generate data from published papers or reports, right. So, these data are pre-processed. We discussed a lot about that. Many cases they are integrated and kept in data warehouses. Remember this. This is something which you must take a note of it. Data warehouses are going to be next important aspects. Why? Because just like you have a lot of big companies like Amazon or other companies where they keep a lot of items as in their warehouses. Similarly, data warehouses also will keep data which are already pre-processed and integrated. It may not be pre-processed also. From that you can explore the data, you can make a lot of statistical summary, you can have plots, you can create reports, that is what is normally done. I have talked about it, how we can plot the data in different ways to get different kinds of trends, and that in a nutshell provides you some statistical summary, following which you are going to use data mining for information discovery. You are going to use all these models to do that data mining, okay, which is basically done by data analyst. Some of you will be working as data analyst, I know, in future. So, there you can create information discovery. What is this information we can get out of the data? That is what is called information discovery. That means, you are going to analyze the data, put in a model, and then discover something. That is what is called like a new material discovery, or you can connect material synthesis with properties, all kinds of things you can do easily. And then you can also present this data in a very systematic or visualization platforms. And finally, end user will like to use your decisions, your final decision, whether I am going to use this material or not this material, okay, that decision. So, in terms of this is a vertical pyramid, as you can see, and finally, you have to provide the decision, okay, and which starts with data sources. That is how we build the whole informatics structure. Okay. So, let us talk in more detail about that. So, data mining has this kind of things. You have obviously you have to use machine learning, pattern recognition, statistical tools, they are related to machine learning, and then visualizations, different kinds of algorithms for statistical tools, high performance computing to do the calculations, database technologies, how to handle databases, and finally, application of these in different aspects. So, basically it talks about confluence of various or multiple disciplines. So, it is not a single discipline, it is talking about different kinds of discipline. We are all learning machine learning algorithms as a part of that. We are not talking about much about database technologies, high performance computing, or various kinds of statistics. We are not talking much about that. So, if you want to learn all this data mining, you need to learn all this aspect. There are different courses also available on each of this. So, your final goal is to have a information science, right. So, that is knowledge discovery, that is what you want to do, right. So, this is a tree like that, where you want to create knowledge. Remember, you go back to my first lecture, I talked about it, how knowledge is important. So, you have databases, you can do data cleaning, integrations, whatever, all these aspects I talked about it, okay, various kinds of things, data integration, data cleaning, data selections, and keep all the data into data warehouses. And from there onwards, what is called selection comes. So, that means data relevant task element data are selected, because data warehouses are everything. It is just like if you want to go to a online store like Amazon, and you will be selecting items which you like to buy, right. So, you have warehouse where all kinds of items are kept, and then from there you will be selecting whatever you want. So, data warehouses will also have various kinds of data for different kinds of subjects, not only material science, but other subjects also. And in material science also you can have different types of data, functional materials, structural materials, different kinds of properties data, processing data. So, you must know which is relevant for your particular problem which you are going to handle. So, this is what is called data or task relevant data. Once you do that, then you do the data mining aspects, I discussed about it, and then finally, you can develop some pattern actually from the data mining. You can also have a lot of machine learning based model applied to the data mining sector, and you can get a lot of information which can be transferred to as a knowledge. So, this is why data mining plays a very important role in knowledge discovery process. You want to first finally create knowledge, discover something new, right. This is the way the tree structure will look like, starting from databases to the pattern evolution. Well, so KDD process can also be together into this kind of ways. So, first you have input data which are integrated, normalized, then you can pre-process data. Pre-process data means you can do cleaning, all these aspects, you can do feature selection, dimension analysis, dimension reductions, and then you do a data mining, which is nothing but a machine learning models are applied onto the data. It can be related to pattern discovery, classification problem, clustering problems, or even outlier analysis. Okay. After that, you have to do some post processing, where you can evaluate the patterns, select the patterns, sometime you can even visualize the patterns, and finally, information is created. Okay. So, this is much simpler way how KDD actually works. Well, that is why material informatics has multi-dimensional view of data mining. It is not a single dimension. First of all, data to be mined, it is extended rational or object oriented, heterogeneous, or even legacy time of things possible. So, you need to have a data warehouses, you need to have a transactional data stream, spatiotemporal data, time series data, sequence data, text, web, multimedia. So, all kinds of data are required, right. It is not only numerical data we think about it. So, you can have transactional data, like you are doing a bank transaction, you can have stream data, video stream data, somebody is telecasting a video. You can also have spatiotemporal data, space and time, like geographical data, right. Then you have a time series data, like something evolving as a function of time, something happening in sequence one after another. Then you have text, whatever, like I am speaking something. Then you have a multimedia like video, and also web, somebody is typing something in Facebook or Instagram or something, right. So, it is like a huge thing, and from there you want to mine that knowledge. That is what is the job of a machine learning person. So, you need to do a lot of discrimination, association, classification, clustering, trends, regression, outlier analysis, descriptive versus predictive data mining, all different kinds of aspects are there. So, we are going to discuss each of this. What are techniques you can use? You can use data warehouse technique like OLAP, we will talk about it. Machine learning techniques I told you, statistics, various kinds of statistics are to be used, pattern recognition, high performance computing, visualizations. So, this is what is the multidimensional view of data mining. Type of data to be mined is massive, and from there you have to create knowledge by using different kinds of modeling, and for that you need to use different kinds of techniques like OLAP, machine learning, statistics, pattern recognitions, and various other things. Okay. So, let us spend a couple of minutes upon data warehouses. Data warehouses must be subject oriented, it cannot be mix of everything, otherwise it is going to not work. So, that means it must be organized around major subjects like physics, chemistry, biology, material science, engineering, all kinds of things, or it can be also product based, customer based, cell based, right. It must be subject specific. It must focus on modeling, analysis of data for decision makers, right, not on daily operations or transaction processing. You cannot do that actually, because then it's become clumsy. So, you have to be focus on the modeling analysis of data for decision makings, and it must also provide a simple and concise view on a particular subject matter, right. That is what is required. It has to provide simple and concise view. So, and also it should be integrated. So, that means constructed by integrating multiple heterogeneous data sources. Basically, when you try to integrate, you have many kinds of problems I talked about. Either you have a problem of data types, systems on which data depends, like metric versus SI units. And then you also have problem of integrations of data in terms of how much data available for a particular data sets, and what are the missing data. Okay. So, and so when it is moved to warehouses, it is always converted. That is what you see. It also be time variant. Time horizon of data warehouse is very significant. Why? Because it cannot be simply talking about historical perspectives, past 10 to 5 years. It has to be time variant in terms of how it is evolving, right. It should provide data in terms of time. So, that is why it must contain elements of time explicitly or implicitly. The key operational data may not contain time element, but it provide this explicitly implicitly element of time. it must be non volatile. Today it is present, tomorrow it is not there, it should not be that. Okay. So, physically separate store of data is required. Many of you heard about it, all these big companies like Google, Facebook, or Meta or something, they are all creating various kinds of data stores, and they put lot of data, which mostly are personal data or your own information from different users. But so that is what we are talking about it, but they are, if they are volatile, they are suppose after some time they are removed, then you have a problem of accessing. So, therefore, many times it may require you to pay some money, transaction fees, but this is what is required. Well, in terms of operation, you can have two kinds of operation, only OLTP or OLAP. So, as you know, OLS is basically what, one line transaction processing, that is what is called OLTP. OLAP is online analytical processing, what is called transaction processing, analytical processing. What is the difference? So, OLTP is basically day to day operations, OLTP, and it depends on the application oriented, data will be current, up to date, and obviously the data size is small, relatively hundreds of MBs. And but on the in case of OLAP, it is basically a knowledge worker, it is not a clerk or IT professional, it is a knowledge worker like you and me, and this must do a decision support, and this must also be subject oriented. That is why you need to have a huge data, sometimes 100 GB to terabytes, and this is something it will be more widely used by experienced users. Okay. So, that is what actually is important for databases. So, let me stop here for the part 1 of the lecture. We come back to the second part and talk about more about this databases and some portion about material mapping. So, second part will be a little smaller than the first part, but we will wind up as soon as possible.